Okay, so what if you could build an entire universe from pure math? We're going to check out an analogy that tries to do just that.
Our story starts in a really strange, speculative place called 81D Kanamori Math. And yeah, this is definitely not your high school algebra. We're talking about some truly out there ideas here.
For example, you have things called psi-PBH fields. Think of them as wells of information, but for abstract ideas. Then there are CRC tensors. These are objects that basically represent compressed information, finding patterns.
And at its very heart is a structure described as the mathematical basis for mind itself. Pretty wild. So how on earth do we make sense of any of this? Well, we turn to a real-world mathematical Rosetta Stone.
And that's the Langlands program. It's this massive project, basically a grand unified theory of math.
It connects two totally different mathematical worlds, the world of numbers and equations, and the world of waves and analysis.
All right, so let's use this Rosetta Stone to translate those strange ideas from Kanamori math.
The entire 81D universe? That maps to motives, which are kind of like the fundamental DNA of mathematical objects.
Remember that CRC tensor we mentioned? It corresponds to a mathematical wave called an automorphic form.
And the universe's hidden symmetries? They line up with the famous Galois group, which is all about symmetries in equations.
But here's the really cool part. This analogy isn't just a simple dictionary, it's a blueprint.
It gives us a direct way to design these new speculative ideas based on real mathematical structures.
So, a real L function from number theory can provide a precise template for a new Kanamori version. This shows us exactly how a key term in that new function gets built from three core Kanamori ideas.
It's a recipe, right? It combines information compression, system fluctuations, and even a concept of value.
And this whole blueprint is so concrete, you could actually sketch it out in Python pseudocode.
So what's the point of all this? Why build this incredible intellectual bridge between these two worlds?
Well, for one, it gives a solid, rigorous language to a speculative theory, using a proven framework as its guide. It really creates a bridge, allowing ideas to flow between this conceptual universe and real, established mathematics. And that leaves us with a pretty provocative thought. What does it really mean to build an entire universe from just math?